Hello and welcome students. This is lecture for 10th standard ICSE and today we are starting with a new topic that is circles. So you all know, you all have already studied circles in lower standard, but we are starting everything right
Good
from the
evening,
scratch.
sir.
Yeah, good evening, very good evening. So in this topic, we are going to start everything right from the scratch. So here you can see that you have the definition of circle. So what is a circle? A circle is a set of points. A circle is nothing but set of points which are all equidistant from a fixed point. So you can check here, you have a set of points. See, you can check here that, see, I draw a circle. So what you see here is set of points, and these all points are equidistant from a fixed point. So see, this point is fixed point. Where is the fixed point? Here, you know, the point about which this is revolving. See, so it is originating from that fixed point, which is the center. And then see the, and then, all these points which you see on the blue geometry, the blue color, these all points are equidistant from which point? From this point. They all are equidistant from which point? From this point. See, these all points are equidistant from this point, and this point is the center of the circle. You call this as center of the circle. This is center. Okay, and then this, suppose I take a point here on the circle. Suppose this is A. So AC, you will call it as the radius of the circle. What is AC? It is the radius of the circle. Okay, now when I was rotating, you must have seen, see, when I was rotating this, now see, this is A, here it is say B, here it is D, E, F. You have infinite points. You see this? There are infinite points. Now all these points, which you are getting on the circle, this makes the circumference of the circle. This makes the circumference of the circle. These all points, they are so close to each other that they make a continuous curve, and this curve is the circumference of the circle. Circumference. If you have 2 points on the circle and you join those 2 points with the help of a straight line, say here you have a point, say B. Now you join these 2 points. See, you have a point A and B here, or for that matter, say you have a point D here. Okay, this is point D. Now you join point B and D with a straight line. So when you join B and D with a straight line, so any 2 points on the circle, when you join with a straight line, you call that as a chord. You call it as a chord. And remember that if this chord is passing through the center of the circle, then the chord becomes the longest chord. Okay, so here I have a point, and I have a point here. I have a point here, and I have another point here. Okay, so this point I have is P. This is point P, and this is point Q. I'm joining these 2 points. So is PQ also a chord? Yes. As you have BD as a chord, PQ is also a chord, but PQ is a special chord. Why? Because it is passing through the center of the circle. Such a chord is the longest chord. You call it as diameter. So PQ is diameter. So this is all you have. And remember that radius and diameter, there is a relation. Radius is half of diameter. Radius is half of diameter, or diameter is double of the radius, because see here, you can check that C to P, you can check here that C to P is also radius. C to P is radius, and C to Q is also radius. So you can understand that P to Q will be, what will be P to Q? P to Q will be 2 times of radius. P to Q will be 2 times of radius. So remember that if you have R as the radius of a circle, if the radius of circle you write it by R, and the diameter you write by D, and diameter of the circle you write it as, say, capital D, then remember that diameter is equal to 2 times of radius. Diameter is 2R. Diameter is equal to 2R, which you should know. So we have covered this point. Then we have covered this point. Now we are having concentric circles. What are concentric circles? Circles which have same center. So here you have a circle, then you have another circle, then you have another circle. Then you have another circle. Then you have see, these all circles have same center. They all have same center. So when they all have same center, whether it is this circle, see, whether it is this circle or this circle or this or this or this, they all have same center. Center is this. You call these circles as concentric circles. Okay. Then you have the next as equal circles. See, equal circles. For equal circles, what is written? Circles are said to be equal or congruent if they have equal radii. Okay. So you draw two circles, and then you draw two circles of same radius. You will call it as equal circles. Okay. If you have three circles of same radius, then they are all equal. Then you have circumscribed circle, circumscribed. Okay. So you have a polygon here, and you draw a circle in such a way that all the vertices of the polygon lie on the circle. Like here, see, triangle. You have a triangle, you can check here that the triangle has three vertices. See, the triangle has three vertices, 1, 2, and 3. Okay, 1, 2, and 3. Triangle has three vertices, and what you see that all the three vertices are lying on the circle. All the three vertices are lying on the circle. So what you say that this circle has circumscribed a triangle. It has circumscribed a triangle. Here you have all the circles, all the points, all the vertices of the quadrilateral are lying on the circle. You will say that the circle has circumscribed the quadrilateral. Okay. Here the circle has circumscribed a pentagon. You can check there are 5 sides, 1, 2, 3, 4, 5. So when do we have a circumscribed circle? A circumscribed circle is the one where the vertices of the polygon are lying on that circle. The vertices of the polygon are lying on the circle. You can read here, a circle that passes through all the vertices of a polygon is called circumscribed circle. The center of circumscribed circle is called the circumcenter, and the polygon is called inscribed polygon. Okay. Next. Then you have, see, after circumscribed, you have inscribed circle. Now, once again, what is inscribed circle? In case of inscribed circles, remember students that you will have the circle touching the sides of the polygon. You see here, the circle is touching sides of the polygon. I can show you one example here. Suppose you have a circle here, right? And now I draw a triangle in such a way that sides of the triangle are being touched by the circle. See. Now what you will say? You will say that this circle is an inscribed circle. If I name this triangle as ABC, if I name the triangle as ABC, then you can check the circle. The circle is touching all the sides of the triangle. This time, the circle is touching all the sides of the triangle. And in case of circumscribed circle, what you saw, the circle was passing through all the vertices of the circle. This is inscribed circle. And in the earlier case, what we had circumscribed circle. Then you know chord. See, let us talk a bit more about chord now. You know what is a chord, okay? A line segment joining 2 points on the circumference of the circle is called a chord. A chord which passes through the center of the circle is called diameter and is the largest chord of the circle. Now look at the 6th point. The 6th point is a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angles to the chord. Okay. So here you have a circle and you have a chord, right? You have a circle and you have a chord. Now what you are doing is you are drawing a line segment by which you want to bisect the chord. Suppose this chord AB is say 6 centimeters. Okay. Now you want to bisect this. What does it mean? It means that you want to bisect AB by a line segment which is starting from the center of the circle, which is O. So what will you do? You will join O with the midpoint of AB, because see, this is midpoint. It is the point which is bisecting, right? So you join O with the midpoint, and when you do that, what happens? You can say that OM is bisecting AB. Now you know that this AM will be 3 centimeter and BM will also be 3 centimeter. They both are equal. AM equals to BM. So what you can say that segment OM, that is segment which a line from the center of the circle is bisecting the chord. The line from the center of the circle is bisecting the chord. And remember, whenever this happens, it is found that the line segment is perpendicular to the chord. So this is a very important property in circle for a chord. What? A line segment bisecting. Okay. a line segment drawn from the center of a circle. If a line segment drawn from the center of a circle is bisecting the chord, then the line segment is perpendicular to the chord. Okay, you can check here. A straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angles to the chord. Okay, this will be right angles. Tell me, students, have you all followed this particular thing? Have you all followed it?
Yes, sir.
This is important. You will all make a note of it. See, here you have a circle. Yes. Now, in this circle, somewhere you have a center. Yes. Okay, let the center be O. Now, you have a chord here. Somewhere you have a chord. The chord shouldn't be the diameter. Now, what you do is, see, this is chord. So, if it is a chord, it will have midpoint somewhere. Definitely yes. So, this is the midpoint. This is the midpoint, M. Now, what you do is, you join O with M. You join O with M. So, when you are joining O with M, what are you doing? You are bisecting this chord. So, this chord is AB. This is chord AB. So you are bisecting the chord. Remember, this will be 90 degree. This angle will be 90 degrees. Okay. That is what is written. A straight line drawn from the center of a circle to bisect chord, which is not a diameter, is at right angles to the chord. Now the converse of this, whatever you had in the statement 6, okay, it's converse. So see what is converse. A perpendicular to a chord from the center of the circle bisects the chord. Earlier what you said that a line segment which is bisecting the chord is perpendicular. You said a line segment which is bisecting the chord is perpendicular to the chord. Now what you are saying? You are saying that a line segment which is perpendicular to the chord will bisect the chord. Tell me, students, you all followed it?
Yes, sir.
Yes. Now we are starting with the next one. See, the next one is, here we have something to be remembered. Greater is the size of a chord, smaller is its distance from the center, and vice versa. Okay, you have a chord which is so see, here we have a circle, right? I have a circle here, and the center of the circle is, say, somewhere here. This is the center of the circle. Now what I do is I draw a chord. See here, I draw a chord here. Now this chord has some distance from the center. And what is that distance? You can understand that distance is this. This is the distance. It is the perpendicular distance. Okay. Now what I do is I draw a bigger chord. Okay, let me now this time have a bigger chord. Say this is some chord PQ. I have some chord PQ, right? Now I go for a bigger chord that is called RS. Now see, this is a bigger chord. You can check that this chord RS is definitely larger than PQ. Now, since it is larger in the size than PQ, you will notice its distance from the center is less. When you talk about the distance, always remember that perpendicular distance. It is needless to be said again and again. Distance is always perpendicular. See, this has to be 90 degree and here also 90 degree. You know, this is CM and this is CN. CN is much smaller than CM. CN Cn is much smaller than Cm. Why? Because Cn is distance of a chord which is larger than PQ. Okay, so greater is the size of chord, smaller is its distance from the center and vice versa. Okay. On the other hand, see, if I go for another chord, try to see this. Now I go for another chord which is much smaller chord. See, I go for a chord which is much smaller. This chord, I write it as UT. This chord is UT. Now this chord is much smaller in length. If I find its distance from the center, you will find that the distance is much larger. Once again, needless to be said that it is perpendicular. You can check that, see, let this distance be Cy. So what you notice? You notice that Cy is much larger. Why Cy is much larger? Because Cy is the distance of a chord from the center, where the chord is much smaller. Tell me, students, have you all followed it?
Yes, sir.
Yes, sir.
Now we go for the next one and see here. The next one is 8 point. There is one circle and only one which pass through 3 given points, not in a straight line. This is also very interesting. See, if I have 3 points on a plane, okay, say I have 3 points on a plane. Now, through these 3 points, let me name them. Say if the points are P, Q, R, S. P, Q, R. I'm sorry, not S. 3 points are there. P, Q, R. Now remember, students, that through these 3 points, you can have one and only one circle. You can have one and only one circle through these 3 points. I have 3 points here, P, Q, and R. Now these 3 points, which are not collinear, they are not on one line. I can definitely have one circle. I can definitely have one circle which is passing through these 3 points for sure. I can definitely have one point which is one circle which is passing through these 3 points. See, this circle which you have, it is passing through 3 points P, Q, R. And remember, students, this circle which is doing so, circle, I will call it as circle passing through points P, Q, and R. Now remember, students, that this circle which you got, it is a unique circle. It's an unique circle, unique. What does that mean? It means that if I try to draw a circle again, which is passing through points P, Q, R, I will get once again the same circle. I will get the same circle. Okay, that is what it says. That is what it is saying. What is it saying? It is saying that there is one circle and only one which passes through 3 given points, not in a straight line. If you have 3 given points, not in one straight line, then through those 3 points, you can have one and only one circle. Now look at the point 9. Point 9 is equal chords of a circle are equidistant from the center. If I go for if I go for two chords which are equal in length, I go for two chords which are equal in length. Okay. So here I have a chord. Okay, so here I have a circle, and the center of the circle is, say, here. This is center of the circle, which I call it as O. Now in this circle, I go for two diameters. I'm sorry, I go for two chords, and those two chords are equal in length. They are equal in length. So here I have a chord, and let us name it as AB. Then I have another chord CD, and CD is equal to AB. How big is CD? CD is equal to AB. You can check, they have equal length. They have equal length, CD. Now remember, since these two chords are they are equal in length, they will remain equidistant from the center. Remember, the length of chord AB is equal to CD. AB and CD, they are equal in length. Since they are equal in length, they will remain equidistant from the center. They will remain equidistant. Remember, O to AB and O to AB, definitely it is perpendicular, and O to BC, what will happen? They will remain equidistant. If I call O to AB, if this is, I call it as M, and here I call it as N, remember that OM will be equal to ON. OM will be equal to ON. Not only that, suppose you have another chord somewhere here. Let us draw another chord here, and say I have, this is AB, and here I have, say, this chord. See, this is chord, and this chord is, say, chord GH. This is chord GH. Now this chord GH is also equal in length to AB and CD. You know, GH is also equal in length. Even GH is equal in length to AB and CD. If I go for the perpendicular distance of GH from the center, I will once again find, say, this I write that this point here is, say, P. The perpendicular distance from the center is OP, and remember, OP is also equal to OM and ON. Tell me, students, is this clear to you? Hello. Vasumati,
Yes, sir. Yes, I understood.
Yeah,
Vasumati, have you followed this?
Yes, sir.
Yeah, tell me, what is it? What did you follow? What you understood? What have you understood here?
Can you hear me, sir?
Yes. Tell me, what have you understood here?
Sir, so we
Here we understood that if the segments, we understood that if the chords are equal in length, then they are equidistant from the center of the circle. If the chords are equal in length, then they are equidistant from the center of the circle. Very good. So here we have done that. See the ninth one. Equal chords of a circle are equidistant from the center. Now the 10th one. Chords of a circle equidistant from the center of circle are equal. It is the converse of that. It is the converse. As you said that if two chords are equal in length, they'll be equidistant from the center of the circle. So the converse of this is if there are two chords which are equidistant from the center of the circle, then they are equal in length. They are equal in length. Now we are going for arc and its types. See, an arc is part of the circumference of a circle. So you can check here, students, you have a circle here. You have a circle here, right? So for this circle, this part of the circumference, you can call it as arc. So sometimes, arc are also called the incomplete circle. So this is one arc of the circle, APB. You can call APB as one arc of the circle. And then not only that, you can call AQB as another arc of the circle. This is another arc of the circle. Okay. So the arc which is larger in length, it is known as the major arc, and the one which is smaller in length, it is known as minor arc. So APB is minor arc and this is major arc. So here what is written? Let us read it fast. See, an arc is a part of the circle of a circle, a part of the circumference of a circle. A chord divides the circumference of a circle into two parts, and each part is called an arc. You can see here AB, which is dotted line. You can check AB, which is dotted line. AB is a chord. Why? What is happening here? You have got a point A and B on the circle, and then this, when you join, it's a chord. What is happening? This chord is dividing the circumference into two parts, and each part is an arc. Now let's go ahead. See, in the given figure, chord AB divides the circumference into two unequal arcs, APB and AQB. The arc APB, which is less than semicircle, you can check. You understand semicircle? Definitely yes. Semicircle will be the half circle. So see here. If I go for see this is quite bold. Let me have, yeah, see. So this is semicircle. Which part? You can say this part of the circle is semicircle. See, this is one semicircle, and here you have the other semicircle. There are two semicircle is half the circle. So remember, students, that in case of an arc, when you have an arc which is smaller than the semicircle, The arc AP, which is less than semicircle, is called minor arc. You see this? The arc APB is smaller than the semicircle. So definitely it is a minor arc. Okay, this is minor arc. APB, the one that is pink in color. This is APB, minor arc. But look at the arc AQB. What do you notice for AQB? AQB is greater than the semicircle. You can check the semicircle. The semicircle is from here to here only. I'm sorry. The semicircle is from here to here. It's only from here to here. But if you see the arc AQB is from here to here. So the arc AQB is greater than the semicircle. What will you call such arc as? You will call it as major arc. Then we go for the next one, students. After this, we have segment and relation between arcs and segment. Okay, see here. So a segment is part of circle bounded by an arc and chord. So you can check here. You have a segment. I will draw a fresh diagram for you. See, students, you have a segment. Let me draw a circle here, right? So you have this circle. Now in this circle, you will have center somewhere. Say this is center O. Now I draw a chord. Okay. Remember, students, when we spoke about just now, just a minute back, when we spoke about arc, what did we say? We say that an arc of a circle is the part of the circumference of the circle. Okay, it is the part of the circumference of the circle. And what is a segment? See, a segment is the part of the circle bounded by arc and chord. It is bounded by arc and chord. So as such, when you say a segment, remember it's a region. So here, if I say chord as AB, you can check AB as a chord. Then the part of the circle which is bounded by chord and arc is the segment. So here now I will go for two segments which I have here. See, this is one segment. You can check this is one segment because a segment is the part which is bounded by arc. So see, this is the arc, and the chord. You can check AB is the chord. So the part of the circle which is bounded, you understand bounded meaning? Bounded means there is a boundary. So what is the boundary of this shaded, blue shaded region? The boundary is one side it is arc and the other side it is chord. See, this is one segment. This is one segment. And then you have another segment. The another segment is this segment. This is the another part of the circle bounded by the same chord, but the minor arc. The minor arc. Remember, students, the segment of the circle which is associated with the major arc, we will call it as major segment. And the one which is associated with the minor arc, we will call it as minor segment. I hope you followed it. Now we have a relation between the arc and we have some relation with regard to the arc and segment of a circle. See, very interesting it is. Theorem 5. See, what does it say? It says the angle which an arc of a circle subtends at the center. The angle which an arc of a circle subtends. What is meaning of subtend? Subtend is a very mathematical word. It is actually makes. Subtend means makes. It makes. Okay. So see here, an angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Okay, so here there is a diagram, and I will try to show it to you. I will try to make you all understand with the help of the diagram. Okay, I'll try to make you all understand with the help of the diagram. See. You can check here. What was the statement? The statement was the angle which an arc of a circle subtends at the center. Okay. So look at this. There is an arc here. The arc is AB. I want you all to focus to the arc AB. Look at this arc AB. Okay. And this arc AB is subtending, that is making, this arc AB subtending an angle at the center. See, this is center. So arc AB is making an angle at the center. That is, the extreme points of the endpoints of the arc, you join with the center. So the angle which you see, this is the angle you see here. You join A with O, you join B with O. What do you get? You get an angle AOB. So what you will call, what is AOB? AOB is angle subtended by arc AB at the center. Now you go for the another angle, that is angle subtended by AB, at any point on the remaining part of the circumference. Okay, so you choose any point on the circumference. At any point on the remaining part of the circumference. So see, you choose any point on the circumference. I chose here. Now what I do is, I join this with point C with the same endpoints of the arc AB. So see here, I join A with C and I join B with C. What I got an angle. I got an angle subtended by same arc. See, once again, angle subtended by same arc AB at a point C on the remaining part of the circumference. Now, as per this statement, you know what they're saying? They're saying that this angle AOB will be 2 times angle ACB. Angle AOB will be double. That is what they're saying. Angle AOB will be 2 times angle ACB. The angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. Remember, not only that, let's take few more. Suppose there are infinite points, so AB, arc AB can subtend infinite angles. See, if I go for this, see here I go for, okay, I take another point, and this time I am taking a point P. So see, AP and PP, AP and BP. What is happening? The same arc AB, which is subtending an angle AOB at the center of the circle, is subtending an angle APB at any point on the remaining part of the circle. Now, once again, this AP, remember that APB will be half of AOB, or you can say that AOB will be double of APB. AOB, this angle will be double of this angle as well as this angle. Tell me, students, are you following what I'm teaching here? Hello, have you followed it?
Yes, sir, got it.
Now see, here we have angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. So actually speaking, this statement can be said in two different ways. First, you learn this, and then I will teach you the second one. Okay. So look at this diagram here. Look at this diagram which you have on the screen right now. Look at this diagram. Angles in the same segment of a circle are equal. We got here AB, which is a chord. You got AB as a chord of this circle. AB is a chord of a circle. Now you know that whenever you draw a chord in a circle, the chord will divide the circle in two parts. It will divide the circle in two parts. Okay. It also divides the circumference in two parts. Okay. So the major circumference, the bigger circumference that you have, you call it as the major arc, right? You call this as the major arc. This one. This is the major arc. And then here you call it as the minor arc, AB here. At the same time, you have part of the circle which is bounded by the arc and the chord. Part of the circle which is bounded by the arc and the chord. Now see, look at this part of the circle which is bounded by arc and the chord. See, I mean the major arc and the chord AB. The major arc and the chord AB. See. Look at this. What is this? It is one segment. It is the major segment. Now, these two angles which you notice, try to understand. These two angles which you notice, they are angle in the same segment. Which segment? The major segment. See, this angle and this angle. So by writing angles in the same segment, what they mean? They mean these two angles. See, the shaded region here, which you see, the shaded region, you see this shaded region, A, B, chord, and then this arc. I have shaded it. See, this is one segment. And if you want to know the another segment, how will the other segment look like? See, this is the other segment. This is minor segment. So when they say that angle in the same segment, they actually mean this. This angle ACB and angle ADB, they'll be equal. That is what they are saying. Angles in the same segment of a circle are equal. Not only that, my dear students, suppose if I make few more angles in the same segment, see, I make few more angles. Let me make few more angles in the same segment. You can make infinite angles in the same segment. And remember, these all angles will be equal. They will all be equal. This, 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 this. If one is theta, they all are theta. Tell me, have you followed it? Tell me.
Yes, sir, I understand.
And see this, and the same thing I said, that there are two ways of saying it. The other way of saying this was the angle subtended by an arc. The angle subtended by an arc at any point on the remaining part of the circle will be equal. You can say this, the same thing you can say in other way. What? The angles subtended by an arc at any points on the remaining part of the circle will be equal. Okay, student, now I want to ask you one question. Can you all tell me what will be the measure given that these all angles are theta, what will be the measure of angle AOB? Can you give me the measure of angle AOB? Hello. What will be
So,
yeah?
AOB will be theta upon 2.
AO will be equal to theta upon 2.
Yeah.
Okay. What is how do you define angle AOB as? What will you call AOB as? It is angle subtended by AB. Where? AOB is angle subtended by AB. Where?
At the center.
At the center. And what did we do just now? If you remember, what had we said? We had said that read this out. Read this out, please. Read it out loudly.
Yeah. The angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference.
What does that mean? The angle which an arc of a circle subtends at the center is double. The angle which the arc subtends at the center is double that which it subtends at any point on the remaining part of the circle. So by which what
Okay, that would be 2 into theta then. Right?
So what will be this angle equal to? This angle will be equal to 2 theta. It will be equal to 2 times of theta. Remember, this angle is always bigger than the angles which are made at any point on the remaining part of the circle. Very good. Excellent. See, what am I doing here? I'm joining D with B. So this chord DB in this circle, chord DB is making once again 2 segments. Yes, it is making 2 segments. This is the major segment. Now all the angles in this segment, they'll all be equal to each other. The angles that you have in this segment, they'll all be equal to each other. Remember this. These all angles will be equal. So what does that mean? It means that this angle and this angle are equal. They are equal. Further, now what I do is, this is done. Okay, forget it. Now I go for another chord, and that is, say, I go for chord AC. I go for chord AC. And then you know what? Look at this. AC will now divide the circle into 2 segments. This is major segment, that is chord AC, and the major arc. See, this is one segment. Now, whatever number of angles that you draw in this segment, whatever number of angles that you draw in this segment, they will all be equal in measure. And that is what, see, in this segment, you have angles ADC and angle ABC. So see, this angle is equal to this angle. Okay. As a matter of fact, if you draw a few more angles here, see, you draw a few more angles. See, even this angle will be equal to remaining 2 angles. No matter how many angles you draw, they will all be equal to each other. See, they will all be equal. They will all be equal. If I call this angle as alpha, they all have the measured same alpha. That is what it is saying. What? The angles in the same segment are always equal in measure. I hope it's clear to you all. Tell me all, is it clear?
Yes, sir.